All right, so we'll go ahead and get started. You can log into Learning Catalytics. There's the session ID over there. And we'll launch right into a question from Monday in just a second. So here are a few brief announcements. I think things are pretty clear here. Not too much has changed. Learning Catalytics. So it seems like we're kind of up and running with that. So today is the first day that your responses will be counting toward your grade. These are largely based on participation, but I also, want you to be making an effort, right? This is why we're doing it, is so that you're learning and actively learning in the class. So please, just make sure that you're participating in those, giving it your best effort. And if you have any trouble with these, I want to make sure that we mitigate them right away. So please send me an email or see me after class if you're having a hard time with those questions getting submitted. The hand-in homework is posted on Moodle, due in lab tomorrow. Okay, and when you're asked to write a description, make sure to cover the things that I'm going to address today in class for you, and just making sure to also use correct grammar and spelling, write incomplete sentences, and also just make sure that it makes sense. So the best way to do this is just hand it to a friend and say, will you just read these two sentences and tell me if you can understand what I'm trying to say here? Okay, that might be a nice way just to double check that you haven't missed something, okay? Online homework. So as you know, Chapter 3, Part 1 is due this Friday. Chapter 3, Part 2 is not yet assigned, but I'll get that up this afternoon. You won't have everything you need because I will not have yet covered standard deviation. So I urge you to wait until Friday to start that, but if you want to, get ahead, that's fine as well. And then just a reminder about that first exam. We still have a little bit of time, but I just want you to remind you that is a night exam. So just to plan ahead, make sure not to schedule anything for that day. Okay? All right. So let's go ahead and jump into Learning Catalytics. So if you grab your device, and I'm just going to, this one's going to be really quick. I just want to remind you that we did this one last class, but it was at the very end. And I want you to just remind yourself about skewness. So we've been looking at histograms, and I want you to tell me, is this symmetric? Okay, we've just been starting to talk about shapes. Is this symmetric? Is it skewed to the left? Is it skewed to the right? Is it uniform? So just review, what that looks like. And just remind me what you think about that shape. Okay, and if you haven't done so already, go ahead and get that answer, and it should be a pretty quick one. All right, so we'll stop that. And 92% of you said skewed to the right, so we won't look at those results there. Okay, now I want you to just look at this and make sure that you understand what a histogram is actually displaying. So this next histogram is the neck sizes of 250 U.S. men. Okay, so it's representing the neck sizes of 250 U.S. men. So which of the following best represents a typical neck length based on what you're seeing in that histogram? Okay, so just tell me which of those three best represents a typical neck length. Okay. And go ahead and get your answer in the next 10 seconds. All right, and I'll go ahead and stop that one, and we'll take a look. So it looks like most of you are on the right track with this one. So I just want to show you, so most of you chose A, 15 inches, and some of you chose B, and this is just the problem that I wanted to mitigate, reminding you that that bar does not represent the neck size, right, in terms of the height. It just represents how many people fell in this bin, right? So there were approximately 55 men who had a neck size between 14 and a half and 15 inches. Okay, so that's what that bar represents. Okay, and then I also want to start addressing this idea of typical. Okay, so we're going to start addressing measures of center today, thinking about, well, what's a typical neck length, and how am I actually going to pick that value to represent a typical neck length? Okay, and so that's what we're going to start addressing today, and look at a couple of measures of center, and start to look at one measure of spread. Okay, so I'll remind you, we were on page 26 of the note, so let's go ahead and go there. Okay, so we just finished talking about skewness at the end of the last class. Okay, and I just want you to think briefly about what types of variables might have a symmetric distribution and similarly a skewed right or skewed left distribution. Okay, so there are a lot of different variables that might have a symmetric distribution. The first two that come to mind are just, if we got the heights and the arm spans of everyone in this class, most likely they're going to have a pretty bell-shaped curve. Okay, some people are going to have lower heights, some people higher heights, but in general it's going to have a bell-shaped curve, most likely. So we can just say heights, arm span, and I'll post those data that we collected in lab on Thursday so we can actually take a look at that and see what those look like. Data that are skewed to the right. This is probably the most common shape that we're going to see in terms of skewness. There are a lot of different variables that end up being skewed right, which you are probably noticing in your homework assignment as well. Okay, and so some examples of this might be, let's record how long it takes people to wait in line at Orange Street Food Farm. Okay, to check out with their groceries. Okay, so let's see waiting times. So remember that when we're sketching out these shapes, this is really just kind of smoothing out, let's say, just a histogram, right? And so we always look at values from the smallest to the largest, just like on a number line, right? And so waiting times at the grocery store. So most people wait between, 30 seconds and say 5 minutes, right? But then every once in a while, you might get there at 5 o'clock. There might be a huge line, and you might end up waiting 10, 15 minutes. Okay, but that's not really the most common occurrence, right? Most of them are going to be here, which represents the higher, that mode right there. Does that make sense? Okay. So waiting times, that's a good one. Salaries. So if we said, the Missoula salaries, okay, most of us would be here, but then we have, there's just a few people who are making, I don't know, 500,000, 750, something like that, okay? And so those are less frequent, right, out in the tail, okay? So let's say we'll just put salaries here. Okay, skew to the left. These are not as common, but can definitely happen, and usually happen when there's some upper bound on a value, okay? So maybe these are exam scores on an easy test where most people are getting, say, 80 to 100, but then just a few people who are not doing as well down in the lower scores, okay? So that might be one example. So we'll just say scores from I shouldn't say easy, but high scoring test. Okay, scores from a high scoring test where there are a lot of people kind of bunched up at that max level. Okay. All right, so those are the types. I just want you to kind of visualize what types of situations you might see in those distributions. Okay? All right, so this section right here, right, we're focusing on the shape of a distribution. We're addressing how many modes that distribution has. Is it unimodal? Is it bimodal? Okay, we're looking at the skewness. Is there skewness? Is it skewed to the right? Is it skewed to the left? And then the third thing that we want to look for in terms of the shape of a distribution is unusual features. Okay? So there might be a host of different things that are unusual to you when you're looking at a distribution. But one of the main things that we're really going to be looking for is outliers. And just the term, you probably can already visualize what that means. Something, right? Something, a point that is very far away from the rest of the distribution. Okay? And when we say very far, you're probably like, well, what constitutes an outlier? Well, we're going to have a measure for that, which hopefully we're going to get to today. But, you know, it's just an unusual value that's far away from the bulk of the distribution. Okay? Okay. So what can we say about the shapes of the following distributions? So I'm actually just going to show you a small description for the Old Faithful geyser. And this is before we have any measures of center or spread to include in our description. So I just want you to take this with a little bit of grain of salt, but I also want you to show, make sure to pay attention to how I'm describing the shape, putting it in the context of the problem, and just trying to give you a basic idea for where those values are. Okay, so let's go back to, you don't have to go back, I'll put this up here for you. But I want to look at those Old Faithful eruptions. Okay. And let's think about what we want to say about these eruption intervals, excuse me. What do you think? Do you think that's unimodal or bimodal? Unimodal. Do you think it's skewed to the left, skewed to the right, or fairly symmetric? Fairly symmetric, I would say. Some people might say, well, gosh, there's a little bit of skewness on the left, and that would be okay. In this regard, I'd probably say, I think I'd not say skewed to the left, but I would also say that there's a little bit of a gray area there, and that wouldn't be wrong. You could say slightly skewed to the left to illustrate these points that are in that left tail there. Okay? I would also argue that, most of those eruption intervals are between 80 and 100 minutes. That gives me a visual for what are typical values for those eruption intervals. And then I also might note the overall range of the distribution as well. Okay, and we're going to focus on this here in just a minute. In terms of, we're going to introduce actual measures of center and spread. But let's just go ahead and write this out. The first thing that I want to tell you when I say describe this distribution, I want you to tell me what the distribution represents. So it should include the name of the variable, right? And kind of give me a little bit of detail. Okay, so the distribution of eruption intervals for the Old Faithful geyser Okay, so tell me what it's about. If you just said eruption intervals, you're giving it some context, but tell me, it's for the Old Faithful geyser. You could even be more specific, saying specifically from 2011 to 2012. Okay, so we're going to say the distribution of these intervals is, we decided that it's unimodal and fairly symmetric. Okay, okay, with a few smaller eruption intervals. Between 35 and 55 minutes. Okay, and then I'll just say that the most typical eruption intervals, 100 minutes. And this I can only get from the data by looking at the exact data, because these histograms bin those values. But I'm also going to say, but they overall ranged from 39 to 122 minutes. Okay, so I just want to point out a couple of things before we keep going. Okay, I just want you to think about these 5 items, and your lab instructors are going to itemize these for you in class tomorrow as well. But when you're writing a description of a distribution, I want you to make a checklist. I want you to address the center of the distribution, the spread of the distribution. I want you to address unusual features. This includes outliers. Okay, I want you to address the shape. So these are in no order, no specific order. And I want your description to be in the context of the problem. Okay, so if you could, especially when you're just getting started with these, if you could write that out for yourself and make little checks every time you know that you've covered one of them, then you'll be doing pretty well with these descriptions. Okay, we're going to come up with measures of center today, so you can actually use the median value or the mean value instead of just trying to eyeball it. But for right now, the center, I would argue, is where I've tried to say most of them are between 80 and 100. Okay, I'm trying to give you a feel for where I think most of those data values are in terms of the where they're centered. And then I'm trying to also say, but they ranged from 39 to 122 minutes. That kind of gives you an idea of the variability of that distribution. I put it in, so we'll just check. Unusual features, not really unusual, but I did address that, we have just a few of those eruptions that were between 35 and 55 minutes, okay? Or I should say 39 as I put in that, because that was the minimum. So we got unusual features. I said that it was unimodal and fairly symmetric, so I got the shape there. And the context of the problem just came from me telling you about these Old Faithful geyser interruption intervals. Okay, so there's the context right there. All right, so we have all of that put together. Okay, so that's what I'm looking for those descriptions that you're going to hand in tomorrow in your homework assignment. Okay. All right, so I'm going to leave the Barry Bonds description until we have our measures of center, and then maybe even the IQR as well. Okay? Any questions about that before I keep going? Question back there? The question is, can I go over how to get the graph onto the piece of paper? I will do my best to get there. I'm trying to get you enough information to completely finish the homework. There is a YouTube video up on Moodle that will show you how to do that, so that if you're struggling with that, if you just go to the videos on Moodle, then you can see that again, if you're still struggling with that. Okay? Okay. Moving on. Page 28. So we have spent a lot of time looking at all these different graphical ways to explore our distributions. Okay, and now we want to know how to numerically summarize them. Okay, so we have 3 different displays so far. We have histograms, we have dot plots, and we have stem and leaf displays, or stem plots. Those names are interchangeable. So we have 3 ways to display a quantitative variable. Okay, and now we want to be able to numerically summarize a quantitative variable. Okay, and there are 2 different things that we're after, just like I mentioned on the last page. We need some way to measure the center of a distribution and a way to measure the spread of a distribution. Okay, and I'm going to introduce 2 main measures that we are going to have for each of these. Okay, so usually we try and report these in pairs based on how they're calculated. Okay, so we can either report the median and the interquartile range. So the median is a measure of center. Okay, and the interquartile range is a measure of spread. Okay, so usually if you're including the median in a description, you're going to include the IQR in a description. Okay, we try to keep them in pairs. Okay, the other pair is the mean and the standard deviation. The mean is a measure of center, and the standard deviation is a measure of spread. Okay, and that's where we're headed in the next few minutes, is trying to introduce first the median and the IQR. So most likely, y'all have heard of median, mean, and standard deviation, and the IQR you might be like, oh, what does that mean? Okay, so IQR stands for the interquartile range, and we're going to introduce how to find those right now. Okay? Okay, so generally we're going to call the median, or denote the median by this big M, and it's nothing more than a value that divides the ordered data completely in half. Okay, and there are 2 cases to consider, the odd case and the even case. Okay, and you can use these formulas if you like. Sometimes they're more confusing to people, and that's okay. You can kind of do it without needing those formulas, but they can be quite helpful. If n is odd, okay, n just being the number of values in your distribution, okay, then I know that the median is going to be at the n plus 1 divided by 2 position. Okay, so if I order all of them, then that's the formula I'm going to use. Similarly, if n is even, then it's going to be, the median is between the n over 2 and the n over 2 plus 1. Okay, and usually the convention to find the median is just to find the average between those 2 values. Okay, and I'll show you exactly what this means with an example. It's kind of hard to visualize that until we actually see what that's doing. So on the next page, we're going to look at an actual example to figure out. Okay, and that little note there is, just to remind you of a couple of things. At school, I tried to drink, tea that had this ginkgo biloba because I thought it would help me, enhance my memory. And so now we're going to look at an experiment where we had a memory score for some taking ginkgo supplements and some taking placebo supplements. And so we're going to talk a lot about experimental design and the importance of of incorporating a placebo when you're testing a drug. But let's just look at these two data, or these two sets of data. So what they did was they assigned these individuals to either receive ginkgo or receive a placebo. Okay, and they took a memory score both before receiving this, drug and then after, and then they took the difference in their memory scores. Okay, so for the ginkgo, right, so then we had, some people did worse, right, -6, and then some people did much better, all the way up to 14. And then we have the placebo scores here as well, okay? So if you count these data, let's just start by finding the median. And I'll warn you to leave some space here because we're going to come back and calculate the quartiles as well. So leave some space here so that you can put those in your notes in a nice way. But if you count all of these values, you'll note that there are 22 people that were in the ginkgo group, okay? So N is equal to 22. Okay, and so this is the even case. And I am just trying to find the median of these ginkgo data. Of course, you need to order them first, right? And then if I want to use that formula, what that says is, we'll just go ahead and take the average of the n over 2 and the n over 2 plus first ordered value. Okay, so let me just write that down. Take the average of the n over 2 and the n over 2 plus 1 ordered values. Okay, so what this really means is, let's take 22, divide by 2. So I need to find the 11th ordered value and the 12th ordered value. Okay, and that is going to be how I'm going to find my median. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this, I'm going to take the average of 3 and 3. So I add 3 plus 3, divide by 2, I get 3. Okay, so the median is 3. So we'll write over here that our big M is 3 points. Okay, so pretty simple. Just keep in the back of your mind that we have not taken into account any of the other values, right? It's just based on position. It's the exact middle value of that distribution. Okay, or in this case, the range of values if you have the even case, but since we have just 2 of the same, then it is exactly 3 points, that median. Okay, so now let's check out the placebo group. The placebo group had 23 people, so this is the odd case. Okay, and remember that back when that gave us the formula on the back page, we have this n plus 1 over 2 ordered value is what we're looking for. Okay, and remember that that does not mean that the median is just going to be 12. It's the 12th ordered value. Okay, so 23 plus 1 divided by 2, 12. So the 12th ordered value is what we're looking for. Okay, so I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm left with that M is 6 points. Okay, so we're going to come back in just a minute and calculate what we call the quartiles. So that's why I'm leaving that other space open there. Okay, so now this gives us, a nice way to say, all right, well, the median for the ginkgo group was 3 points. The median for the placebo group was 6 points. So just based on that, it seems like the ginkgo group was actually doing worse than the placebo group. Okay? So there we go. Do you think that this difference is significant? 3 versus 6? Yeah, so it might be interesting to actually, instead of just looking at those medians, might be interesting to look at the distributions and figure out how much variability there is in those distributions for us to get a feel for whether or not we think there really is a difference there. So that might be an interesting way to look at that, and we'll talk about that very soon here, looking at those. We could look at what we call a back-to-back stem and leaf display even to look at those too. Yeah?
You also want to know the subjects, because what if you're dealing with like elderly or people who have memory problems?
Oh, yeah, absolutely. So we'll get into a lot about that. So the question is, wouldn't you want to know who these people are in terms of whether or not the ginkgo, is effective? And absolutely, we'd want to know a lot more about what's going on in this experiment. Right, like who are the subjects? How were they selected? How was this treatment actually imposed on them? There are so many things that are going to really affect our conclusions and how strong of a statement we're going to make about these differences, right? And we'll talk a lot about that when we start talking about experimental design. But yeah, good point. Okay, so we have those medians there. Okay, that is a measure of center or spread, the median? Center, okay? Okay, moving on. Now we're going to look at what are called quartiles and define the interquartile range. Okay, first I just want to make a quick definition. You all know what this means. Okay, there's a simple measure of the spread of the data, and it's called the range. And this is just the difference between the maximum and the minimum. Okay? So it's just the maximum value minus the minimum value. It's a single value, okay? However, if I talk about it like it's a verb, if I say my distribution ranged from 0 to 100, that's okay. I'm using it in a different context. But if you're using it as a statistic, it's a single value. So you can say the range of my distribution is, and then just give that number. Okay? So note that that is a single number. Okay, so if the range is just the maximum minus the minimum, the interquartile range is going to have a similar flavor, but it's going to be the range of the middle 50% of our data. Okay, and now I'm going to show you how we're going to calculate that. Okay. So you all have heard of percentiles before. Okay, so when you took either the ACT or the SAT and you received a score, and it tells you what percentile you were performing at, okay? And if that was 80th percentile, then you were, then 80% of the test scores were at or below you. Okay, so 80th percentile, that means that 80% of the distribution was below your test score. Okay, so you performed better than 80% of the people who took the test. Okay, that's the basic idea of a percentile. Okay, so let's think about looking at a distribution. I think it makes sense to talk about it being the greatest from the largest value all the way down, or the greatest, largest, I should say largest maybe, down to the smallest in terms of the values. Okay, Okay, and just envisioning these on a number line. And let's imagine that I have a distribution that has 20 observations, okay? Okay, so I have 20 X's there, essentially just representing, my data from the smallest value up to the largest. Okay? So let me see where my median would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be right in the middle. That's going to be my M. Okay, so if you think about it, the median is just the 50th percentile, right? 50% of the distribution falls below the median. Okay, so that's the 50th percentile. Okay, but I'm also interested in breaking up my distribution into quarters. Okay, so I want to split these upper 10 observations into 2. So I'm just going to say 1, 2, 3, 4, 5. I'm going to cut that in half. Okay. This is going to be my Q3. Okay, that's the 75th percentile. That means that 75% of the distribution falls below Q3. Similarly, if I cut the lower half in half again, okay, then I'm going to get what we call Q1. Okay, and Q1 is going to be the 25th percentile. Okay, so Q1 is called the first quartile. M is the median. We never refer to it as the second quartile, but you're welcome to think of it that way. Okay, and then Q3 is the 75th percentile, and it's the third quartile. Okay, so it's worth just memorizing those, just to know that Q1 is the 25th percentile, Q3 is the 75th percentile, and then I think you'll know, or you'll remember that the median is the 50th percentile just based on that definition. Okay? So by just noting the largest value, Q3, the median, Q1, and the smallest value of a distribution, you actually know a lot about it, right? If I were to just give you those 5 values, that's quite a host, that's a lot of information. Gives you an idea for the center of the distribution, and also gives you a feel for how spread out the distribution is as well. Okay? I do want to point out that there are several methods for computing Q1 and Q3, and I'm going to illustrate the method that is done in the textbook, not to mean that one is any superior to another, but I just want us to all be on the same page. So when I ask you to calculate the quartiles by hand, I want you to do it in the way that we're using in class, okay? Just so that we can all be consistent and it's not confusing. And then when you're asked to compute it for a large data set, then you can just use StatCrunch and use the method that StatCrunch uses. And I'll say more about that soon. So when I ask you to get those quartiles for the homework assignment that's due tomorrow, then you go ahead and just get them with StatCrunch. Don't do it by hand. Okay. Let's see here. So how are we going to get these quartiles? The first thing we're going to do, of course, since these statistics are based on ordering our data, we are going to first order the values from smallest to largest and find the position of the median. Okay? Then there's going to be 2 cases again. Okay, we're going to have the even case and we're going to have the odd case. Okay? And so I just want you to have this kind of starred in your notes so that if you forget what to do for the even and odd case, you can just go back. Okay, so we'll just put on here finding the quartiles in your notes so that that description can be there to help you remind you what we did. Okay. This is the one that is a little bit different depending on what textbook you read or what software you're using. Again, we're going to be consistent with the textbook with how we do that. Okay. So let's go ahead and go back to the data, and we'll look at how we're going to find those quartiles. So let's go back to those Ginkgo. Okay. Okay, so I have found the median. Now, this is the even case. So what I'm going to do is I know that since it's even, I know I can split those, split the data into two equal halves. Okay, so I can visualize this by putting these brackets here. Okay, and you know from page 30 of your notes, all we're doing is trying to cut each of the halves in half again. Okay, so now what I'm doing is I'm going to try and find the median of the lower half of my data and then the median of the upper half of my data, and those are going to be my Q1 and Q3 respectively. Okay, so I could use my median formula again if I want to. Okay, but I'll just point out that we have we have 11 data values between -6 and 3 inclusively. Okay, and since that's odd, I know I'm going to have a unique median, and that's going to happen right here. Okay, so this is going to be my Q1 is going to be 0 points. Okay, and then similarly, that Q3 is also going to be the 6th ordered value. Okay, 1, 2, 3, 4, 5, 6. Okay, and that is going to be my Q3. So Q3 is going to be 7 points. All right, so if you're confused about how to find that 0 and 7, you could again use that formula, right? If you say, okay, well I have n, you could certainly do it this way. N is equal to 11, okay? And then you could say, well I need to find the median. Where is that median for when I have 11 data values, right? And I'm just going to take, well, this is going to be the 11 plus 1 over 2 is the 6th ordered value. Okay, so that's how I know that I'm looking for the 6th ordered value in both of those. Does that make sense? Okay. Okay, so now I have the median Q1 and Q3 for the Ginkgo group, and then I'm also going to get in a similar way the Q1 and Q3 for the placebo group. Now I have the odd case, okay? And this is where I want you to make sure you see what I'm doing here. Because what I'm going to do is when I split since it's odd, I can't split the data exactly in half, okay? So what I'm going to do is I'm going to include that median in both halves, essentially. So when I get the median of the lower half of the data, I'm including that 6. Okay, and when I get the median of the upper half of the data, I'm also including that 6. So I include it in both sides. Okay? So some textbooks will choose to exclude that median. Okay, and there's no right or wrong answer. There are just different methods for doing it. Okay, and this is the method that we're going to use. Okay, so now, if I'm looking for the median of the lower half of my data, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So I have 12 data values. So now I'm going to take the average of the 6th and 7th ordered data values. Okay, so this is going to be, my Q1 is going to be, if I just average 3 and 4, this is going to be 3.5 points. Okay, so Q1 is really any value between 3 and 4, but it's generally accepted to just take the average of that 3 and 4, okay? Okay, similarly, I'm going to do the same thing here, and I'm going to find that Q3 is going to be the average between 8 and 8, which is just 8. So Q1 is going to be 3.5 points. Q3 is going to be 8 points. Okay? All right, so moving on to back to page 31, let's go back and answer our question here. So I illustrated for you that even in the odd case, okay? And now I just want to go back and find Q1, Q3, and the IQR for both groups. We already found Q1 and Q3, but I want to illustrate how to find the interquartile range. So we have the Ginkgo group. Okay, we had Q1 was, was 0 points. Q3 was 7 points. So the IQR is Q3 minus Q1, which is 7 points. Okay, so when we say interquartile range, all we're saying is it's the range of the central 50% of the data, okay? And so we're just going to take the difference between those two. All right, so again, interquartile range is not two values, okay? It's just a single value that represents the range of the central 50% of the distribution, okay? Let's similarly do that for the placebo group. Okay, so IQR is just, again, Q3 minus Q1. So that is 8 minus 3.5. And we're left with 4.5 points. So that gives us a measure for the spread of the distribution. Okay? So now you have a way to measure both the center of a distribution using the median and the spread of a distribution using the IQR. If you are struggling with getting those summary statistics out of StatCrunch, please check out that video. There's a video on YouTube. If you just go to Moodle, there's a video on how to do that. Or if you're struggling copying and pasting into your homework assignment, you can see a video on that as well. And send me an email, or there's Study Jam tonight, and there will be 3 people there tonight. So I know that there were not as many last week. Have a great day.